Hey, my dear students, welcome back. I know, exams are so close, right? And the tension is probably building up. But hey, don't you worry one bit. Your favorite tutor is here to make everything, and I mean everything, super simple. So today, we're going to do a super quick revision of the entire Relations and Functions chapter. The goal? To make sure you walk into that exam hall feeling like a champion. And hey, if you haven't already, hit that subscribe button and don't forget to tell me in the comments which chapter you're scared of next. Chalo, let's get started.
Have you ever thought about this? You open up Swiggy or Zomato, right? You see all those restaurants. You pick one and bam, instantly you get a whole list of every single food item they have. What the app is doing is actually pretty simple. It's just pairing that one restaurant with every dish it sells. And guess what? This simple idea of making all the possible pairs, well, that's exactly where our chapter begins. And in the world of mathematics, this big, giant master list of every possible pair, well, it has a fancy name. We call it the Cartesian product. Now, don't let the name scare you. It's the simplest thing, and it's the foundation for literally everything else in this chapter. Simple, right? Okay, let's see how it actually works.
Okay, let's take a super simple example. Imagine we have two sets. Let's call them set A and set B. In set A, we just have two colors, red and blue. And in set B, we have three things, a bag, a coat, and a shirt. Now the big question is, how many different combinations, a color paired with an item, can we actually make? Let's try and figure that out.
Okay, let's do this one by one. First, let's take red. We can pair red with the bag, right? That's one. Red with the coat, that's two. And red with the shirt, that's three. So three pairs with red. Now let's do the same thing for blue. Blue with the bag, blue with the coat, and blue with the shirt. That's another three pairs. So what's the total? We had two items in the first set and three in the second, so 2 times 3 is 6. 6 total pairs. See? Ekdam simple.
And there you have it. This complete collection, this set of all 6 of those pairs, that is what we call the Cartesian product of set A and set B. We write it as A cross B. It's literally just the set of all possible pairs you can make. The only rule is that the first thing in the pair has to come from the first set, and the second thing has to come from the second set. That's all there is to it.
Okay, now for a question that the board examiners absolutely love. This is a favorite, I'm telling you. So pay attention. They'll give you something like this. If the ordered pair x plus 1, y minus 2 is equal to the ordered pair 3, 1, then find the values of x and y. Now, I know it might look a little complicated with the x's and y's, but trust me. This is one of the easiest, most gift-like questions you could ever get.
All you have to remember is one super simple rule. If two ordered pairs are equal, it just means their first parts are equal and their second parts are equal. That's it. So let's just do that. We take the first parts and set them equal. X plus 1 equals 3. A little bit of simple math, and we get x equals 2. Now for the second parts. Y minus 2 equals 1. Solve that, and we get y equals 3. And you're done. Full marks, just like that.
Okay, so we've got our master list of all possible pairs, our Cartesian product. Think of it like a giant buffet with every possible food combination. But what if you're on a diet? What if you don't want all the pairs? What if you only want the ones that follow a certain rule, like maybe only the healthy options? Well, when we start applying a rule and picking out specific pairs, that's what we call a relation. Let's look at an example to make this crystal clear.
Okay, check out this diagram. On the left side, we have a set with just a few letters, and on the right, a set of names. Now, see those arrows? They're not random. They're following a rule. The rule here is an arrow connects a letter to a name only if the name starts with that letter. So, A points to Ali. And look at B. It's pointing to both Banu and Binoy because both names start with B. This special selection of pairs that we picked out based on our rule, this is a relation. It's just a small part, or a subset, of all the possible pairs we could have made.
All right, now for some vocabulary. There are 3 key terms you have to know. First is the domain. That's just the set of all the things where the arrows start. So in our example, it's A, B, C. Simple. Next is the range. The range is the set of all the things where the arrows actually land, the names that got picked, right? And finally, we have the codomain. The codomain is the entire second set, all the names, even the ones that didn't get an arrow pointing to them. Just remember this, the range is always a part of the bigger codomain.
Okay, so relations can be a bit casual, but now let's get even stricter. I want you to imagine a type of relation that is super disciplined, a real rule follower. This very special, very strict type of relation has a special name. We call it a function. And to be a function, it has to follow two very, very important rules. These are non-negotiable.
Okay, Bacho. Listen very carefully. These two rules are the most important part of this chapter. For a relation to get promoted to a function, it has to follow two rules. Rule number 1. Every single element in the first set, the domain, must have a partner. No one gets left behind. Everyone must participate. And rule number 2. Each element in that first set can have one and only one partner. It can't be two timing. It can only point to one place. Got it?
So let's look at a rule breaker. This diagram is a perfect example of what is not a function. Look closely at the number 9. See how there are two arrows coming out of it? It's pointing to 3 and it's pointing to -3. It's trying to have two partners. This breaks our second rule, right? One input cannot have two different outputs. So this relation, sorry, you are not a function. It's as simple as that.
Okay, now let's look at a good one. Let's see if this one follows the rules. Let's go through our checklist. Rule number 1 is everyone on the left side playing the game. Let's see. 1, 2, 3, 4, 5. Yep, they all have an arrow coming out. No one's left out. Good. Now, rule number 2 is anyone two timing. Does any number have more than one arrow leaving it? Nope. Each number is pointing to exactly one partner. So, both rules are satisfied, which means this relation is a function. Perfect. So, let's just put it all together. What's the big difference between a relation and a function? Think of it this way. A relation is pretty chill. Some inputs might not have an output, and one input could have multiple outputs. No big deal. But a function is super strict. Every input must have an output, and each input must have only one output. That's the key difference. By the way, this is a great slide to take a quick screenshot of for your last-minute revision. All right, you ready for a quick fire round? Let's meet some famous members of the function family. You'll see these guys everywhere. Now, you don't need to be an expert on them just yet, but you should definitely be able to recognize what their graphs look like. You know, just like you can recognize your favorite cricketers or movie stars from a picture. First up, on the left, we have the identity function. It's f of x equals x. It's just a perfectly straight diagonal line. Why? Because whatever number you put in, you get the exact same number out. It's like looking in a mirror. Now, on the right, we have the very famous modulus function. F of x equals the absolute value of x. Its only job in life is to make everything positive. That's why its graph has that classic V shape. If you put in a negative number, it just flips it up and makes it positive.
And here are two more interesting characters. On the left is the Signum function. This one's pretty simple. It only ever gives you three answers. -1 if your number is negative, 0 if your number is 0, and 1 if your number is positive. That's it. And on the right, we have the greatest integer function. Now this one's graph looks like a staircase, doesn't it? That's because its job is always to round your number down to the nearest integer. It always takes you to the step below.
Phew! Okay, we have covered a lot in just a few minutes. So how about we do one final super fast revision just to lock all of these ideas into your brain for good? You ready for that last little confidence boost before the exam? Let's do it. So let's just quickly recap the whole story of this chapter. It all starts with the Cartesian product, right? That's our giant master list of every single possible pair. Then we get a little picky. We apply a rule and choose some of those pairs, and that gives us a relation. And then we get really strict. We find a relation where every input is used and has only one output, and that's our function. And remember, the set of all the inputs, that's the domain. The set of all the outputs you actually get, that's the range. And there you have it. The whole chapter done. See, what did I tell you? It's really simple when you break it down. You've totally got this. So please, don't stress about the exam. Just relax, make sure you understand these basic concepts we talked about, and I promise you, you will do great. Trust me on this one. All right, before you go, one last little test for your memory. I mentioned a very famous function whose graph looks exactly like the letter V. Do you remember which one it was? Go on, type your answer down in the comments below. I'll be looking out for them. All the very best for your exams, Bacho. You're going to be amazing. I'll see you in the next one. Bye-bye.